Okay, so I've started to record this now. Okay, well, as I say, welcome everybody to this webinar. What we're going to cover today, myself and Mark, are some simple junction design, slip roads, and geometry changes. So effectively, what happens if your geometry changes? I think it's fair to point out that we're aiming for sort of 45-50 minutes, and we'll finish before 1 o'clock, as we know people are limited by an hour at lunch. So bear in mind these are fairly simple examples of what you can use to an Open Roads Designer, but hopefully it will give you the idea of what we have available. And the kind of tasks that you can perform. Everything that we're showing is something that you can do in MX or Inroads or Power Civil, any of the legacy products. So the aim of these webinars has been to show the technical work that you can do, that you've done in your legacy products, and how to do it now in Open Roads Designer. They're all, as we said right from the start, we've tried to do real world situations here. Okay, so as I say, welcome to everybody. Thanks for attending. So today's agenda is as you can see on the screen, a few introductions and housekeeping for those who haven't met us before. Some base. Then I'm going to go through a basic junction design using civil cells. Then Mark's going to do some work on slip roads, retaining walls, nosing, tapers, etc. And then there's a few non-technical bits and pieces at the end that we'd like to talk about. So as an introduction, I'm not going to go through myself and Mark's experience again, but I've kept this slide in just for those of you who may not have attended any of the previous webinars. As far as housekeeping goes, as I say, we aim to hit 45-50 minutes, but it might drag on closer to the hour. The session is being recorded, and I will make sure that everybody who attends the session gets the link to either a recording, either the ability to watch it streaming on WebEx or to download an MP4 file. So if there's anybody else who you think might want a copy, please get them to get in touch. So far, we've had lots of people who have been watching these online after the event as well. We really appreciate everybody attending these. We've had over 100 people at both sessions so far, which Mark and I are blown away with, and more importantly, our bosses are blown away with as well. So this is doing us a lot of, giving us a lot of ammunition within the organisation to make a success of these. And again, feel free when you get the invite to share them around it in your organisation as much as possible. As far as we're concerned, the more people we have at these, the better. So that's the introductions and housekeeping over and done with. So first off, I'm going to talk a little bit about simple junctions. There are, of course, a number of ways of designing junctions within any of the software that you might be using. What I'm going to show today, and bear in mind, as I say, we have limited time, is how to use some of the civil cells that we have available certainly within the UK workspace. This is what I'm using here. What I'm not going to do today is create some civil cells from scratch. That's a little bit more than a sort of 20-minute demonstration. It's distinctly possible that if there's demand there, we may include an hour session on creating civil cells some way down the line. More than happy to do that if people think there's a need for that. And I certainly think that it's something that people should be aware of that you can do. So there's some small creation tips. We'll look at actually placing one of the civil cells that we've got in the UK library. I'll talk around what the placement involves. Particularly useful tool is the clipping boundary. We'll look at the civil cell library that's available in the UK workspace. and then editing, geometry changes, and finally some housekeeping at the end of what to do with simple junctions. Okay, so less of me talking. I'm going to now shell out to OpenRose Designer. Okay, what we have here is a, a DGN here, which has got a 2D view where we do a lot of our design, and it's got a 3D view zoomed in on some of the junctions here. I've shown the 2D at the moment is in wireframe, and the 3D is in smooth modeling, because it just gives you a nice, better idea of what the design looks like. So, as I say, it's fairly simple geometry. We have a terrain model, and we have a very simple road designed with a couple of side roads on here, just tying into the main, as you can see, tying in quite nicely to the main carriageway. What I wanted to indicate here is that the junction design is irrespective of geometry. So on the inside of curves, on the outside of curves, and on straights as well. Neither of mine are on straights though. So as I say, we have some simple geometry here. So civil cells, you probably don't know a huge amount of about civil cells, but they're effectively, what a civil cell is a microstation type cell with civil intelligence built into it. So you can build in surface templates, geometry, end conditions, all of these sorts of things that you're used to designing with your standard corridor modeling. So anything that you really can do in corridor modeling, you can do in a civil cell. And if I go back to my detailed design, adding detail, we can see here we have the place civil cell option here. So what have we got under civil cell? Well, obviously we've got place civil cell. Does really what it says. Create civil cell, processing the civil cell, and dropping the civil cell. We're really just going to look at the place civil cell option here. Creating civil cell, as I say, I mentioned previously, we supply a library within within all our workspace, and particularly the UK workspace. It's not complete yet. We're in the process of adding more junction types to our civil cell library, and I'll explain a little bit later on how civil cells hang together within the workspace and the setup. So let's get on with it and have a quick look at how to place a civil junction, to create a place junction. So if we go to place a cell, we get the civil cell dialog over here, and it asks us first for a civil cell name. There's a little browse button here, which allows us to pick a civil cell, and these are all the ones that are in the UK workspace. There's a lot of standard ones that we have, and there are also some specifically for the UK workspace as well. If you look here, there are also some roundabouts which will come on at a later session as well. I'm going to look at the basic T rural civil cell, and as you see, you always get a priority on a preview on the right hand side panel when you pick it, and you can see some of the other ones, and I say for roundabouts, various bits and pieces in the roundabout that you can do as well. But as I say, we have roundabouts as one of our sessions later on in the program. And really, once you've picked which civil cell you're going to use, it's a case of following the prompts on the heads-up display. So the first thing it's asking us to do is to locate a reference element. That's the through road, edge of pavement, profiled. bear in mind that to place a civil cell, I think everything has to be either everything has to be null or everything has to have a profile. I don't think you can mix and match. So the first thing it's asking us to do is to locate the edge of pavement. For this road, I know I've got a feature definition which is edge of pavement, element edge of pavement left here, so I'm going to pick that. And then it's asking to locate a reference element, the secondary road centre line. It's also telling us that the profile has to be for a minimum of 25 metres. That's because the civil cell that we've designed is 25 metres from the giveaway line. So it could be more if you design your civil cell in a different manner and you'll get a different prompt. So I'm going to locate my secondary road, and what it then does is give us a preview of what it's going to be to do. There are, of course, several solutions, and if we click around, we can give the several solutions for this particular combination of data. I'm not going to show those, but effectively you could have the junction coming off the other side of the edge of pavement line or the other side of the side road reference. But as I say, it's not relevant in this case because we want to show it as it is. It always comes up with the obvious one first, in my experience anyway. So reset on that. Now it allows us. This is quite an important one. Select corridors to be clipped. So this is what this is. You can pick a corridor here in order to clip it, clip out the corridor details, the details of the corridor when you place the civil cell or when you place the junction. So I'm going to pick my main corridor here. Now, if your side road had a corridor as well, it doesn't in this case, but if your side road had a corridor as well, you could choose another corridor to be clipped as well. The clipping is done to a clip boundary, which is included when you create the civil cell. In fact, the last thing you do when you're creating the civil cell is you can add a clip boundary to that, that's automatically included in the civil cell. You don't have to create it on the fly as you're going through. So select corridor to be clipped, which I've done. Reset to complete. And you can see it's placed. It's now asking us to accept the civil cell placement. So if I click on here, what it's going to do is going to place the civil cell that we have designed here, and you better see it appear in the 3D model as well. So I'm just going to click accept to place civil cell, and it processes through, and it's doing a fair amount of work here, so it does take a little bit of time to complete. But as you can see over here, we now have the junction tied in. It's clipped everything out, and you can see it's placed a junction here. What I'll show also on the 2D display, hang on a second, if I go back to the 2D display and show this as smooth modeling as well, we'll see what's been clipped out. So smooth modeling. So we can see here on our 2D plan what it does indicate, and I hadn't really appreciated, I haven't really had a chance to edit the civil cell. There's a couple of things which don't tie in. We'll see that the hard strip on the civil cell doesn't quite tie in, so we could go back and edit our civil cell, and also some of the feature definitions don't tie in particularly for the civil cell as well. A little bit of a cosmetic issue there, but we can see if we pick our civil cell, highlight our civil cell, you see everything is clipped out, and if we go back to our main carriageway as well, you can see it's clipped out the bits that are included as part of the civil cell. And it's really as simple as that. I'm going to go back to the wireframe on my 2D. It's as simple as that as for placing a civil cell. The hard work here really is creating the civil cell in the first place, and as I say, that's not really a 20-minute demonstration. If I show the same thing, we can go through and place another civil cell on the outside of a curve, and we'll see that it ties in. I should have created some saved views here. We'll see really the same thing. Locate reference edge of pavement, locate reference element, skip, select corridor to be clipped, reset to complete, acceptable cell placement, and it goes through and places us another junction up here, and you can see everything's clipped, and it produces us a nice junction up here. As I said, the actual placement of a civil cell, it's fairly straightforward, fairly easy to do, fairly repeatable, and it's an easy way of producing some simple junction design. There are, of course, several ways you can do this in a bit more detail. You can use linear templates to create your junction and not use a civil cell at all, and add details by creating lines and converting them to 3D elements. So, maybe for some of the more complex right-hand turn junctions, you may want to do that from scratch. And again, it's something we can include in another session. But we thought it was quite useful to show civil cells in this case as a really quick and easy way of producing some good simple junction design quickly and easily. As far as how it's set up, I mentioned that the civil cells is part of a library, and it certainly is. If we go into Windows Explorer and browse down to our UK standards folder, then they are stored in a DGN lib, a civil cells DGN lib, and we'll have a look at these in a second. But these are all held in your workspace and in a config variable as to where to look for the DGN libs, and there's various DGN libs, and DGN libs are simply DGNs, which are library files, and you can save out any DGN as a DGN lib, and it's really a library. And if we actually go and look at one of these, look at the T intersection DGN lib, then we get a 2D and a 3D view of each individual junction that's in that particular library. So you can see these are the same ones that came up for us when we looked in our when we were picking our civil cell, and also, as I say, these are the DGN libs, and the T intersection DGN lib is the file where this library is stored. And you can add to these. You can add more you can create yourself a DGN create yourself a civil cell in this particular DGN. You'd go to here, create civil cell, or you might just want to take a copy of it here, and you can go in and edit the either the features, or for example, we could change the radius here to 15 or whatever it is we want on this junction. Save it away, and then that's available for us to use as a slightly different one. The best thing that we've recommended to people is just copy this, paste it somewhere, do your edits, and rename it to something else. So you can quickly build up a library of simple junctions. And as I say, this is a real first stab from us. I think I mentioned at the last webinar that we were still building up the UK workspace, and this is something where we certainly can put a bit more work into producing all of the a UK junction library to be used. As I say, it's basic at the moment, but as I say, you can. The intention was always with these was for people to add their own information to DGN libs and use them. And as I say, it's fully editable here. With radius, feature definitions, offsets. Remember, there's a problem with the offset here, so we could easily edit the offset of this particular element here. And update, and it would update our as we went back to our main display, we could reprocess the civil cell, and it would update according to what was now in the library. So as I say, edit in the library, process the civil cell, and it'll update what's on our main design. Okay, so back to our our main design here now, and so we've placed a civil cell. What else might we want to do? Yes, we can. I've mentioned something here, dropping the civil cell. I'm not going to do it in this instance, but you can actually drop the civil cell. And what that means is, rather than everything being attached to each other, being related to each other, you can drop it back to its constituent parts on the DGN. So everything will come back to go back to its individual elements. You see at the moment when we highlight it, it's a whole civil cell. If we spin through the individual elements, you can see you can get to those as well. But by dropping it, it will take it back to its constituent parts as we had on the DGN lib. So, but we can of course edit on the fly as well. So, for example, if I wanted to change a radius of one entry curb, we can change that to 15, and which one is it? It's this one down here. So if I change that to 15 and hit enter, it automatically reprocesses the civil cell, and you can see, check out the 3D view here, and it updates everything automatically. It recalculates the clipping required and redesigns our junction on the fly, as it were. And all these things, all the things in the civil cell can be changed. So you can change offsets of string, offsets of lines, widths, etc., etc. And as you do it on this particular junction, it updates all automatically. As I say, you can go back and change the DGN lib and create yourself multiple features or multiple types of junctions in that DGN lib, or you can edit each individual one as you want to on the fly, as I just did here. And of course, there's an undo button which takes us back to our previous design. Okay, so that's editing the individual junction. One thing we wanted to mention today was what happens if you change your geometry as well. Okay, so all of these, when you place a civil cell, remember we were asked for an edge of pavement and we were asked for a center line. So all of these, this civil cell is ruled to this edge of pavement. And the edge of pavement, because we've designed it as a corridor, is ruled back to this piece of geometry center line. So they're the rules that are associated with this civil cell. So for example, if we needed to change our side road geometry, and I appreciate that what I'm going to do is not particularly realistic, but it gives the idea of what happens if we move our geometry for one of our side roads around. So we can then snap to, let me pick a snap to somewhere else on our center line as I'd done previously. If we snap to there, and it reprocesses the civil cell, and with a following wind, as you can see, we've moved our geometry center line, and it's moved our civil cell, it's moved our junction, and it's recalculated the clipping boundary for the corridor as well. So you can see here it's moved everything because there's rules associated with the center line and with the edge of pavement line. It knows what it's attached to. The design intent is there, and it will move everything that needs to move. And the same thing with our main road geometry as well. Again, this isn't particularly realistic, but for example, if you move your main centerline geometry around, let's just move it out here a little bit. Just keep your eye on the 3D model now and change our main centerline geometry, and it reprocesses the corridor, it reprocesses the side road, and it should, there we go, have moved everything and clips everything back up again. So it's doing quite a bit of work here, so it does take a little bit of time. But as I say, not a particularly realistic example, but you can see here that it does heal everything up automatically. So any changes to geometry, because everything's ruled back to each other, any changes to geometry, and everything else that's ruled to that particular element changed as well. Okay, time's getting on. If you've got any questions, then type them in the output window, and I'll have a look at them while Mark's doing this presentation. Oh, just one thing more I wanted to quickly show as well. If we look in the Project Explorer, we now have, I should have shown this before, but we now have civil cells here, and it gives us information about the civil cell that we've designed. The one at the top here is Civil Cell 2 Rural references, so it tells us what our external references are, the through road edge of pavement and the secondary road centre line. So it's telling us lots of information about those references that it's used. Dependent elements, so these are all the elements that are associated with the civil cell, and corridor clipping boundary. So there's information about, that's the name of the boundary within inside the civil cell. So you can see the Explorer has a lot of information about the civil cells as well, and also you can actually go in, and the way I find it easier to delete a civil cell, if you're not happy with it, just delete a civil cell, away you go, and it should delete this civil cell, reprocess the corridor, and it heals everything else back up. So we no longer have our clipping boundary done, etc., etc. So fair to say as well that there is plenty of information available on civil cells on both the communities and the Learn server. I haven't got communities. I meant to have the communities open, but there's a fair number of videos, etc., etc., both on the placement of civil cells and the creation. And I also believe there's a Learn server training course on the creation of civil cells as well. If not, then let me know. I certainly have some information, and we're doing some internal training next week, which includes civil cells. So Mark and I are getting a little bit more training on civil cells next week as well. Okay, that really concludes my section. I see we've got a couple of questions in the output window. I'll endeavour to answer those while Mark's carrying out his presentation. So I'm going to stop sharing my screen now, and it's over to Mark to do something on slip roads. Mark, are you there?
Yes, I'm here.
Okay, I've stopped sharing mine now, so you can share yours now.
Okay, let me know when you can see it.
Yep, I can see it. I'll mute myself now, so it's over to you. Thanks, Mark.
Okay. Welcome. So, hello everyone. Today I wanted to show you how to use the... let me show you this first. So today I will show you how to use the comments we seen during the last webinar to create a slip road. We will create a taper and a nose, and also tie in the slip road to the main line by merging their verges and their slopes. We will also have a look at how we can widen the carriageway in the curves. Then we will see two capabilities to update our design and what you can do if your alignment changes and you need to update your corridor. And finally, how we can add a retaining wall in a corridor when you need to follow a road length limit, for instance. Okay, so for this first part, it's more a review of what we did last time, so I won't spend too much time on showing and explaining how to create the nose, taper, and adjustment, as we already know the tools, but it's worth to see how you can use them in this particular workflow. So the project is the one we used last time. We have the motorway here, and we will work on this ramp, so this slip road. So the first step to create your, so the nose here and also here, we will merge the two verges. the first step is to duplicate your template drop. So if I go in copy template drop, we can select a corridor. So let's start with the slip road. I will use this line also, this construction line, to help me for the design. And so the first template drop will go from the beginning to the back nose. So in this case, it will be 85 meters. I'll validate it. I do it again for the verge part. So it will be here from the back nose until more or less after the intersection of the two verges. So let's say here. And I do the same thing for the main line. So let's copy also the template drop from here to there. And again from the same corridor, from this to there. Once we have the template drops created, we can delete the components we don't need on the template, as we saw last time. So I can edit my template. In this case, I will delete the slopes. I don't need them. The verge also, and I will keep the art strip here because I will use the point control to tie into the main line. Okay, the same thing on the main line. So let's edit it. In this case, I can delete the slope, the verge, and the hard shoulder. I don't need them. So you can see in the 3D view it's updated. And we do the same thing for the verge. So I edit this on this slip road. I delete the slopes. I keep my verge this time. And I edit the main line. I will keep my hard shoulder, but I delete the slopes and the verge. Okay, now that the templates are okay, what we can use is the point control to direct the, I'll say, the hard strip point of the slip road and tie into the carriageway of the main line. So the first step is to select our corridor, the stations, so from 85 meters, so from tip to back. We can give it a name, so it will be nose. We choose which point we want to control. It will be so the art strip, and the mode will be, we need to control it vertically and horizontally, so both. We select which element will be, so linear template it will be. We select the element, we give it a priority, so it's 1, and we don't need any offset. Okay, now so we can see it has been done. We repeat the same operation for the verge. I select my corridor, the stations, and I give it a new name, so verge. I look at my point, so it would be the verge. And same thing, I need to control both. I will use a linear geometry, and this time it will be the edge of my hard shoulder. Priority 1, no offset. And like this, we have one element. Yeah, maybe not, it wasn't the correct one. I used the carriageway instead of the hard shoulder. So I can go back here The corridor, point control. No, it's not in the motorway, it's in the ramp. So we have point control, verge, and we use the wrong point. So we can, if we know the name, we can change it here. In this case, I don't know it, so we can delete it. And recreate it. So let's do it again. Select my corridor, the stations, that would be this one until this one. Verge, my points will be the verge. Both linear geometry, arch shoulder, and this time is okay. Now we can see that it's not really what we want, so what we can add is a key station here. And we need one thing also I wanted to show you. It's, for instance, if you see that you have too many lines and you're not able to see the right one as it happened to me before, you can also decide to not to display the construction lines. So here for the template and for the corridor, by not displaying the constructions. So like this, you will have only all your design elements, and you can use the Explorer to add your elements. So for instance, now I want to add a key station. I can go in my corridor, right click, and use the different options here. So key station. Now I want my key station to be just a bit further at the end of the back nose. So we know that is 80 meters, so I can put it at 85.01, just 1 centimeter. And like this, we can see that is much better in this case. Let's have a look with the cross sections to see if everything is fine. This time I need to display my constructions. I want to display the slip road on my third view. Okay, here it seems to be correct. Let's see a different station here. So where we have the verge controlled by the hard shoulder, so it seems to be fine. And the last part we need to work on it will be the slopes. So at the moment you see we don't have the slopes because I didn't activate the terrain. Like this is much easier when you work on your carriageway. You don't really need your slope to be recalculated every time you modify something. So you can just not activate it. And now that I need them, I can just go back and activate my terrain model. Once it's done, you reprocess your corridors. So the first one will be the slip road, and reprocess the main line. Okay. Like last time, we see that also we have the two slopes that are crossing each other. We don't want this situation, so we can use the target aliasing on the slip road, and we define the corridor as the first target and our terrain as the second one. We apply it, and now so it's okay. We have on one side we have the slope reaching the corridor first, so stopping it. And if we want to match to finish the slope of the main line at the same point, we can use the corridor clipping. So we select our corridor, the main line, the one that we want to use to clip. We right click, and you see that now we have the two slopes meeting at one point. You can also remove the clipping if you don't need it anymore, or if you do an update of your corridor, I would recommend to remove the clipping before and do them again after. So I want to delete it. I do the same process, right click, and it's back as before. More or less it was what I wanted to show you for the slip road design, so for the nose, for the verge behind, and now I wanted to show you also for the curve widening. I will show you how to use the curve widening command, which is also here, create curve widening. It's used to automatically create and apply horizontal controls to widen a lane around curves. The tool, I would select it, is used, let's say I select my corridor. Here is the window you will have. So it uses a WID file that you will by default find in the UK dataset here, which contains the parameters for the widening. If I open it, let's with a notepad, you can see that you have different information. So first the radius, 0, 100 is the one by default. The widening inside of curves here, the length of transition inside of curve, and the same thing for outside on both sides. Okay, so I keep it, and you can choose so the stations where to apply this curve widening. You can give it a description. You need to choose which points you want to modify. In this case, we will use the edge of pavement, and the percentage of transition. So between, in the case you don't have any spiral with your curves, you can balance the transition on your elements, so your lines and your curve. And if you have a spiral, like in this case, you can use it directly, and you have two options to choose for how the transition will behave. Okay, now we have done it. We just validate the information. And now we can see so the curve has the width is much larger, so it happens, it works, and you have here point control element showing that it's inside the corridor. Okay, enough for the slip road. Now, how do we tie in the main line to the slip road with the taper? To do it, I will use a geometry element here. Geometry. You have different, of course, elements for the design of your geometry. But one thing that is really interesting here is how you can create offsets of an existing element. So you can decide to create a single entire element partially, and you can use a taper. So you can make an offset with a variable, say, width of an element, so variable or ratio. We will use the variable one. And okay, the value here is the one we should use. So it's a bit strange because we start larger than we end. Is because the start point will be this intersection here, the tip of the nose, not the beginning of the taper. So I select which element I want to recreate, which station we start. So we start by the end, and I want it to start at this point, and we go backward. Let's say for the moment I just draw it in this way. So we have our construction element, and as you can see, we have all the different parameters of the creation available. In this case, I want my taper to be 150 meters. So it will be designed here. And once I have this construction element, I can modify my corridor and create a new template drop here. I will use one that I've created. I added the taper lane in this corridor from validate it. So from the beginning of the taper until the end here. Validate the different values. And now you can see that we have it, and we can use simply point controls to change the width of the taper. Select my corridor, the stations, the same ones here, the end. I give it a name, so taper. I locate my point. I want this time just to control it horizontally. It would be a linear feature, and it would be this element. And yes, I want it as a secondary alignment. If you remember, it's because like this, all the elements on the other side will be perpendicular to this line. So it's what we want for the ditch, for instance. Don't want any offsets. And we have done our taper. On the 3D, everything seems fine. So we have finished the design of the slip road on the slip road and on the main line. The next thing I wanted to show you is what you can do when you have a change in your geometry. So the first thing that happens is what also Simon showed you, is if you change your geometry, your corridor will automatically be updated, so it will follow the new change. But with the corridor, we have a different command that is quite useful. It's called corridor reattach. So if you key it in here, so you will have corridor reattach. Basically, you can just change the baseline of your corridor. For instance, you need to use this new baseline for your corridor. Instead of recreating it, you just go, select your corridor, select the new baseline. I will use the active profile, so I right-click. And all your corridor shifts to the new alignment. You can see the change here also in the 3D. That's for the corridor reattach. And now I wanted to talk a bit more about the second capability, what we call the design intent. Generally speaking, design intent builds associations and relationships between civil elements. These relationships include geometric information, such as offset and elevation differences between elements, but go much further and even allow designers to snap two elements to dictate their intent. That elements depend on one another. So elevation information about the objects is stored to capture the designer's intent, And in the event an element is modified, any related elements will recreate themselves based on these stored relationships and owner original intent. So let me show you some examples. So for the nose and the verge, I use my construction element. And let's say, for instance, now I don't want this length to be 85 meters, but I want it to switch a bit more. So let's say until here. OpenRoads Designer will remember the snap you did before, so it will automatically recreate the template drop at this point and update the corridor. So like this, your nose is much longer. And as you can see, the key station is here because I entered the station and I didn't use a snap to do it. We could also do it here. Also for the taper, for instance, if we decide we want it not to be anymore at 150 meters but 175, let's say. So you see, so yes, this template drop were adapted until here, so this one not, but it can be because I didn't snap properly the first time. So in this case, but the good news is you don't have to change the point controls, you don't have to change the stations for your corridor, so you still save a lot of time. Okay, the last thing I wanted to show is how you can use a template to create a retaining wall in this case. Okay, let's see a cross section. Ah, yeah. Okay. Just an example here, we have the road length limit, and we can see that our slope is going much further, and we need to create a retaining wall. We want a retaining wall with the height that varies along the corridor, and to do it, you can use a template. If, for instance, I will show you, if we create a new template drop in this area with one I've created before, so here you can see this template drop here. Okay, I will create it. It will be easier to understand after. From the beginning until the end of this limit here. I validate the values. Okay, now we can see the new cross section. And what we want is I'll say the end of the slope to be tied in with this limit, and the retaining wall to be higher at this level, so and to follow a slope of 50%. We can do it by setting up some, I'll say the way it worked on the template drop, and once you've done it, you can just control this point, so the limit of the point of the slope. So the same thing, we use the station, so you need to define the station from here until, yes, it was this one. We call it retaining wall. Choose our point. Want to control it both. Produce in linear geometry, and we don't need to be a secondary alignment. Okay, now we can see that the wall is taller, and if we go to have a look here in the 3D view, okay, we have the wall here, and your slope is following the limit. Okay, to sum up, we've just learned, we saw how we can use different template drops, point controls, key stations to design a slip road junction, and how we can adjust the components with target aliasing and corridor clipping. We had an overview of how we can update a corridor if the alignment changes, and how to use the design intent in order to update our features automatically by association. And finally, we were able to design a retaining wall and adjust its height in function of an external constraint. Is what I wanted to show you today.
Thanks, Mark.
Okay. I stop sharing?
Yeah, please. We're nearly off top of the hour.
Yes.
So
yeah, I tried to accelerate at the end.
Yeah, we did this yesterday, and it took us 45 minutes. But hey, look, I just want to share a couple more things. Any Bentley news? There's a few events, and as I mentioned last time, the training is always available. There's nothing new on updates at the moment, or releases. The next release is of Open Rose Gina is due end of Q1, so that'll be the end of March. And I've been told by our management, if we manage to keep the numbers up, there may be potential for a mini conference somewhere in the UK later on this year. So let's encourage people to attend. We're a little bit down this time. There was 84 here today, so please encourage people. I've had several apologies, and I'm sure people will watch it online as well. And also, just a date for your diary. We may do a mid-March additional presentation, something on basic drawing production, so how to get some cross sections, profiles and plans using named boundaries out. It will just be maybe half, 3/4 of an hour, although this is supposed to be an hour. So keep an eye out for that, maybe somewhere around the second Thursday. Mark and I will have a discussion next week, see if we can get to it on time. So keep an eye out for that one. Apart from that, you know where to get hold of us. You can log service requests, or you can email us directly online. The next one is due to be the 28th of March, and we'll be covering overlay design. So the next scheduled one, 28th of March, but keep an eye out for around the 14th of March for potentially a quick drawing production one. I just want to thank you all again for attending. The recording, I'll make it available in the next few days or so, and keep an eye out for that. And thanks again for attending, and look forward to seeing you either in 2 weeks or 4 weeks. Thank you very much. Bye bye.